Yo, what's up? I'm back from the whole odyssey regarding the food that was started about, damn, 4 hours ago, I think. 4 hours ago. Wow. Time flies. Time flies. Time flies all in the wrong places, am I right? Well, time flies when I'm also at my job, so that's fine. If we make a test, let's make a test. It does the right number of things, and actually this test passes, but this does not. Why? Because the pattern is a bit too small. Here it should be 3 3 4 3 3 4 3 3. Instead, look how it should be like. It should be 6 5 5 4 5 4 4 3 5 4 4 3 and 4 3 3, then again 4 3 3. So yeah, I think now we have to kind of expand it. I think we have to expand it. Also clean it up a little bit, you know. Okay, so let's recap. This is where do we reach 3 by 3 by 3? So 3 by 3 is 9, by 3 is 27. So 1 2. All right, I'm gonna count in Slovenian. I'm gonna count in Slovenian just because I'm not that good in counting in English. 1 2 3 4 5 1 2 3 4 5 6 7 8 9 10 11 12 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So right over here is 27. So what do we have here? So right here we end up with 4 times 4 times 4, if I'm not wrong, because 4 times 4 times 4 is 64. Is it? Damn, like let's I need that pocket calculator, or maybe shit, maybe calculator, mate calculator. 4 times 4 times 4 64. So 27, 28, 29, 29, 30, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8, 3, 9, 3, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, 8, 4, 7, 4, 5, MP, 2, MP, 3, MP, 4, MP, 5, MP, 6, MP, 7, MP, 8, MP, 9, MP, 60, 80, 20, 30, 40. Yeah, that is 4 times 4 times 4, which amounts to 64, which is great. Now, if you hear crying in the background, that's some neighborhood kid who is angry, I guess. So yeah, that's 4 times 4 times 4, and to advance from 4 times 4 times 4, we have to do like this thing again, and after that we need to get 4 times 4 times 5. So I'm gonna use my little sketch over here. 1 2 3 4 5. 1 2 3 1 2 3 4, and then times 5. So you say 5 4 4 3, and then 4 3 4 3 3. Alright, we got that already. So we say 5 4 4 3 4 3 4 3 3, and I'm kind of feeling stupid, you know, because it's always the same from the beginning, and then it's 4 3 3, and then again, of course, 4, but I always love to check it, you know, 4 3 3 and 4 3 3 3 and 4 3 3 3, and then again 4 3 3 3. What's up, kitty? I think I need to clean her litter box. So what is happening here is a little bit more complex. Now we got that. Oh, did we just miss like 1 2 3? Like here it's 4x 4x 4, which equals to 6 4, and 1 1 2, and then it's 5x 5. So how do you do 5x 5? Well, they say it is the same as this, except, oh my god, is maybe my algorithm flawed? Because if we say, like, copy that, and we say, oh no, it's still like, it's not flawed, it's 4 3 3 3 3, and the next one is always the same. Alright, so I think I have enough like visual data to construct a solution, because what do we see? It is where are we starting again? We're starting at here, step 12. So we're starting at here. Yes, because we start with empty next line elements. And so we say after first increment number of 3's, and second increment, so with this logic here should be 3 of them, but it's only 2 of them. Here is the 3 of them. Alright, that's kind of simple math, I know, but not for me. It's like the J song, it's like the jazz song, but not for me. And let's say you have x in range all, like, you've got it over here, and let's test it out. Is there a way to test it against the bigger thing? Why is it failing? Because of the buffer size. Alright, if we test it against a little bit bigger thing, like this one, changes 7, changes 22. Oh, that's all correct, and it failed for 37, of course, and for 59. So what do we have here? We have this we have those steps, and to get on my level of understanding first, we have to make those steps a bit more steeper, and that is to make the same thing. Well, I need to go to the toilet. I always need to go to the toilet when I start thinking, you know? Yes, so we're back. Yeah, that took another 2 hours. I know. I think, yeah, it did took 2 hours. So yeah, that's like I think 6 hours, just like so. All right. Yeah, so we're concerned about these steps, and we see over here that if this is our first step, this course of action is appropriate, and the second also, but the third one is not. So we say right over here, when you say for x in range number of lines, let's try to remedy that with the thing that we say threes counter. Yeah, we need to like imitate pattern that we have from here, sadly. So it says 3 counter plus is 0, and for x in range number of lines, so then we say do we really need, no, we do not need 3, we only need number of lines. And this the 0th one, this is the first line. So we say always the first line, this is the second, oh wait, this is the first line, this is the second, and we say every third line do nothing. Every third line say x minus 1. So we say, oops, if, so how do you recognize every third line? We say if number of lines modulo 3 equals 0, you say 3x minus 1, else we say 3 just like before, yeah, 3 times times x. So we make an attempt on that, and we get a colossal failure. We get a colossal failure. Because we applied it in the wrong way. We should not have done any of this. Oh, because we are not concerned about the number of threes, we're concerned about this one. The whole loop should not run. So we say if, and we say range if x, now if number of lines modulo 3 equals 0, we want to break the loop, and we lose nothing if we break the loop. So okay, and we do get a pattern that we want, kind of. Oh, okay. If so with this loop, do we pick out the right line? You know, because we say this line should be, so we got 4 3 and then 4 3 3, and then this one should be, this growth should be stunted, so this should be 3 3, and the next one should also be 3 3 and then again 3 3, but that doesn't happen. So we've got two problems now, and we are on our way to solve one. That's great. There may be that if we were a bit, I'd say, experienced, maybe even brighter, that we could get two pigs with one stone. So if number lines 3, instead of breaking the whole thing, we then say if how do we get the, if x equals to number of lines, and we say, I think this shall never happen because number of lines, like x started at 0, so we say I think this should never happen. So if it does happen, it shall print out rook was wrong, and I shall get again, look, rook was right is what's up. And we can happily see that there is not that many wrong answers, you know. All of these things are correct. The only thing is that buffer size reached its limit. No, they're not correct. What am I talking about? So if we say rook was right, if x plus 1 equals to the number of lines. So this should occur for every line after the basic ones, after the starter. Rook was right here. Rook was right once, rook was right twice when it's 3. Alright, so if only then we say break. Alright, that does not look good. Okay, it is just the nature of that test. That does look good. Let's see more of them. That looks even better. So 4 3 4 3 4 3 3 4 3 3, and then we say again at so we got this one, and then so we say 2 1 2 2 1 2. Yeah, we got that right. That's the first thing is solved. The next thing is the number of threes, because the number of threes is not 1 2 3 4 5 like it's here, but it's rather 1 2 2 3 3 4. So we start at 1, and I guess here I would have less trouble if my starting position was here, because it is always that when the ready for a short break in 10 seconds, because it is always if the So we see that whenever there is like this big jump here, it's kind of hard for me to get this, but I'm getting by. Whenever there is look, there is a small jump, it increases by 1. There is a big jump, nothing happens, and after that also nothing happens. So that's a harder one to crack because it occurs throughout. So how do we base it? Instead of saying 1 for 1, what it does actually, this is, yeah, but this is a bad case, I guess, to measure it up against. I'll take a pause again to take a shower. Alright, so I'm back and I got an idea. Because the thing is regarding the number of 3's in this thing over here, we could make a pattern of how they are supposed to look like. So here, let's say here is, because actually this is the first one, like over here, so we say 0, and then that takes us to over here, it's 1, that's 1, and that's, and there's 2, and then there's 2, and there's 3, and then there's so 1 1 2 2 3 3, etc. Now, how do we address this? How do we say? Is it divided by 2? If this is the first one, divided by 2, floored down is 0. Can we do it like so? 3 is x floored down. 2 divided by 2. Is that the proper way? For list and int. Well, yeah. It has to be like so. Why so? Oh, it's done wrongly. Maybe we need to do 0 plus 1. All of them pass. Oh my god. Why? Alright, now, for real, now I don't know what's up. All of them pass, come on. Oh, maybe because they don't use this thing enough. Let's see. Let's see what's wrong. How much is it? $69. 3. This should be right. Because we got 64, there's 69, so we say, yeah, that checks out. That does check out. That checks out. And that goes for way too long. That should go for 3. And okay, we see our little solution is not enough. And what we could do is say, more simply said, that with this way we could make another variable like a face count again and do it according to that. Because when we are at the bigger numbers we see, yes, this does not work good. This should not be here. So the problem is even over here. Yes. I'm sorry, just a moment. Yeah, the pen was resonating on top of the refrigerator. So here is the problem, that right even here it should not be that amount. So I guess our solution was not that great, because it does not do right, and it is connected, it is not separate, it is connected. We see it here. But I mean, if we go back, that is fair. We just need a way to solve this. 3 is that, and 4, 3. Say elif number of lines floored by 3 equals 1. That happens here. Here is the thing. Then oh no, it's 2, right? is 1, 2, 3. 1, 2, 3. 1, so that's 1. I did shoot myself in the foot. Or not. Because if I just say if x is 0, then do nothing. But so I say that if and that and x is not 0, then say next line elements extend. We want to extend it in that case, and because we tie this for the number of lines. What is that? Oh, it's alarm to get to sleep. Just a moment. Because there is a function to this pyramid, but it's not as it is over here. And so we got the 3 thing out of the way. We just need to get the redundant for 3 pairs, and with them also the 3 ones, because we say we did all of that only no, it's not right, because it's 1, 1, 2, and then it's again 3, and then it's again 4, and it's 5. I mean, if we make an attempt again, it shall be something weird, you know. It will go infinity. Yeah, look, what an ugly thing. What unruly mess I made. I think I shall be not able to solve this today. Yes, sadly. Not. But we stayed here. And it's a quite good step ahead. If you ask me. 3, 4, 5. Tonic was good in the first one. So we might as well test it out. Yeah, we dissolve the test space, of course. There's not enough tests. Oh! Hey, hold on, with this it works. No, it doesn't. 1, 1. Yeah. I mean, here we should say, just so we go, like, number of threes, or threes phase. We start at 1. So we start here and do x times round down. I say Python round down. Python round down. Best ways to round it down. Round number and digit. So if we say round and we've got and digits, round 1.5 is 2. Damn it. Round 1, 1. Yeah. Also use floor, certain digit with math. We can use math floor int. What? Fuck you. Yeah, this does not work for that one. Fuck, man. Like, how do we then decide? Where are you? How do we then decide, you know? How do we decide? How do we decide? Because there it is just a simple counter. And every two. Oh, so it is 1, and we just say number of threes equals 1. So this is times number of threes, and in the end of this one we just say if threes, so we say threes face plus equals 1, and if threes face equals 3, say threes face down to 0, and if we run that, I think we should, oh, okay, maybe we would see the 1, 1. Let's see it over here. It's got, oh, okay, we got 2, 2, 2. Yeah, too many of them. 2, 2, 2, 2. What? Huh? Number of threes is 1. if 3's face is 3, say number of 3's plus equals 1. Okay, we got 1, 2, 2, 3, 3. Is that correct? No, it's 1, 1, 2, 2. So we should start at 0. So you got 1, 1. Oh, now we got 3 ones. What if we start with, instead of 1, if we start at 2? Oh, shit, what did we do? Oh. So, no, I think we changed wrong variable. Number of 3's, we should do 3's face is 2. Tempt. 1, 2, 3, 3. Okay. Maybe 0. Make an attempt. Fuck you, what the fuck? If it's 3. Yo, I tried 1. Right? It should be like 2. Oh, fuck it, this one. Oh, it's already, okay. Starts at, yeah, it should start at 2. It's 1, it's alright. Come on, it should be 1. Oh, fuck, no, it's 1, 2, 3. We're talking about the same fucking shit. It's 2. Oh, changing up number of 3's instead of. Okay. 3's face plus 1 if that is 2. And say 0. Tempt. 1. It's immediately 2. If this is already 2. Maybe we are doing a classic fallacy. Because in the end we are always doing something with the 3's. 1, 1, 1, 1. Number of 3's plus equals 1. 3's face is 0. 3's face is always plus 1. Oh. So it just started 1. Tempt. No, my logic is so fucked. So I think we got it now. Let us see. 1, 1, 2, 2, 3, 3. 1, 1, 2, 2, 3, 3. 1, 1, 2, 2, 3, 3. We got that down. Damn right. 1, 2. Then we got only 3. We got 3 of them. Alright, we got that thing down with a little bit trial of error. We must congratulate ourselves for making this good of a print statement. Now for the right amount of these things, because we need to stop. We need to stop, and we say maybe if we have is the number of threes following. Oh shit, getting ahead of myself. For x in range, and say so what's the problem? This thing is wow. Oh, okay, so this is filling out a line, and this thing must not run. This thing must not run. Sometimes say if x plus 1 number of lines break, and also or the length of this one is stunted by this thing. So you say or if the number of threes plus 1 if that is less than x. So let's see what do we get. Yeah, we get this weird thing going on. We get the wrong thing going on. So we say number of threes or number of fours in the line in the beginning, it's always 1, right? It's always 1 and x is 1, and here is 2 and x is 2, and here is again 2 although the x is 3, and here the x is 4, but we need only 3 of them. When does that happen? It happens like this. We say Great. And maybe we just need to say or or, and we just say like over here, shit, number of fours is plus equals 1, because over here whole thing breaks, also the number of 4 breaks. So you say or if x is larger than number of fours. Yeah, x is, I guess, never larger than the number of fours, or is it? Or let's just make another, like, fuck it, let's just make another one. Say, if x is larger than number of fours, say break, and also print out x is larger than number of fours. And that never happens. Yo, that really does never happen. That x is larger than the number of fours, but it should happen like right here. It should happen. Am I saying it right? Number of fours is always 1. At some point to just say that. But I guess it just never fucking does, right? Excellent. Never does. No matter the thing. Cause why? Yeah, why? What if we start at 0? Number of fours. That thing just never runs. Yo, that thing just never runs. Number of fours is 0. So let's say like print f is x of fours is number of fours. Of course, this is all gonna be green. 1, 2, 3. Yeah, it is 1, 2. Oh, it's 1, 2. Yeah, 1, 2, and then it's 1, 2, 3. Because it first, yeah, it first already here. Because it says step 1, 2. Number, let's just say number of fours should be yeah, number fours. So here is oh, when we do it like so, so we say 1, 2, 2, 3, 4, 4, 5, 6, 6. So we say 1, 2, 2, 3, 4, 4, 5, 6, 6. And then I guess if we follow this fashion, and it is always the same as 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Oh, maybe, just maybe, when the break thing is like break should not affect anything else, right? This break works, but not really. So yeah, what the heck? Yeah, cause why is that one going strong? 1, 2, 5, 6, 1, 2, 5, 6. It's wrong. It's another one of this Python magic that I do not understand. That I think is the last challenge to understand. Why is that working when there is line break? If that, say, I leave do that, and then we say else, just else, to check, yeah, test that out. Oh, okay. Oh, so we were basically working with the faulty one. Because I guess some things must be over here. I guess some things must be out of it. Test this out. Oh, it doesn't pass. Well, oh, maybe because actually now this oh shit. Wow, yeah, let's trace it back up until when it all worked. Here it did work. So if x plus 1 equals number of lines, set break, and that worked. Let's just see what what does that do if we say Python break, Python break statement. if condition is true, break. Goodbye. Forgotten in Python. If that break type oh, like it completely stops it. And yes, it should completely stop it. And we can see, can there be two break statements in one loop? Break, break, break. Yeah. It is the else if function. And to put to comment all of this out. Still making a oops. We should just run an ordinary test. Still everything is green. And to put all of that in an L under an else statement. Here say else. Yeah. The cat is demanding. The cat is demanding. Shit, I need to take care of the cat. Alright, that does not work anymore. So I had a false, so I need to repair that. First let's comment this out. Because apparently we need some things to carry over. Say if x, this number of lines, is x plus 1 equals number of lines. You may ask yourself, what is that BS expression? And there is a lot of bullshit in this code, and that is why I think it is important to write good code. Because there at some point maybe we have already reached that point with this amount of code where I do not understand it anymore and we have to rewrite it all over from the ground up. But with good codes, the thing is you do not have to rewrite it because you understand it and you can work on it. So but this gives us a better opportunity because it shows that we have managed to make our code run the last time properly with good intentions but wrong means. Oh, there is some weird nested if statement over here going on. What the fuck? Okay. So we were already here before. I think. So here we say if number of lines, let's just break it. But we must count the number of fours. So we say number of fours. Say number of. The pattern is correct, right? It's 1, 1, 2, 2, 3, 3, 4. Yeah. You say if number of fours is greater than x. Now, if x is greater than number of fours, then we want to break. And I guess that will so we started numbers for 0, x is 0, 1, and we also then need the fourth phase, because with the fourth phase we got increment by 1, increment by 0, increment by 1, increment by 1. So we got 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0. So it's 1, 1, 0, 1, 1, 0. And we just need to like get it phase. Yeah, with these phases it's really confusing. I know. There's lots of things confusing. Lots of things that are confusing. So to say number of fours is 0, and we got fourth phase. Now where does three's phase actually oh, okay, sorry, this here, fourth phase. So if it is, if I understand correctly, if it is 1 1 0 1 1 0 1 1 0 start. If it is 1 1 0 shit 1 1 0, here we started 1 0, so there are 3 parts, and we start with the second one. So here we say we are second, and that's the three's phase, and then we say here where is fourth? I need to like oh shit, control find. Oh, you can't do that. Is there anywhere fourth phase? So there's always number of fours is +1. Alright. At the end of each one you say fourth phase plus equals 1. So then you say, oh sorry, then you say if fourth phase equals to 3, because now it does 1 2 3, or we could just say again 1, and here if we start at 0, 1, 0, 1, 2. So we got 3 states now. If you say +1, fuck you, short breaks, you're fucking distracting me, you fucking piece of save files. Yeah, more like, oh, sorry, I'm cursing, I said I won't curse that much anymore. Alright, let's just rest our eyes. But now we just say count if there is the third phase. We say oh, and we're here, right? 1. What am I counting even? 1, 2. What am I even counting? Jesus, number of 4s. So here is 1, here is 2, here is 2, here is 3. There must be no more than that. Fourth phase. Because that's a bit more complex, right, than this one. 1, 1, 2, 2, 3. This is 1, 2, 3. This is 1, 1, 2, 1, 1, 2. And over here it was 1. It was 1, 0, 1, 1, 0, 1, 0. And here is 1, 1, 0, 1, 1, 0. And so maybe here fourth phase should be 3. Starts at 1. If it's 1, 1, 0. The fourth phase 3. You say number of 4s is ought to be 0 at this point. We say else for, oh no, number, oh shit, no it's not, oh, what am I writing? Number of 4s, oh, nothing happens. Just say pass, right? Else. You say pass and say fourth phase set back to 0. Else you just say fourth, oh no, just number of 4s, say plus equals 1. Oh, no, this one worked and this one didn't. Is it the right way? Are we starting at the wrong fourth phase? Huh? It really does not make a difference, I guess. Okay, that does not make a difference. Yeah, it should start at 3. Oh, shit, here we have 5, 5, 4. 4, 3, yeah, that's right. 4, 3, and then it's 4, 3, 3. Oh, we got that issue again. with just assigning instead of it's 27. Oh damn. 37 changes. There are 37 changes. 433. 433. 543. 43. 433. 4. Oh, okay, I see. This should be 5 instead of 4. I see. Is this like 4's face and 3's face messing it up? 2 maybe. Wow. Okay, this is nightmare. Well, the sad thing is I won't be able to work on this tomorrow because I'm gonna stop right here. Because I'm working tomorrow and the day after tomorrow for the whole day. So unless I wake up in the morning and make sense of this, there and I don't know if I maybe do it on Thursday. I don't know. Maybe even tomorrow. I don't know if I get it, because right now I cannot get it. Maybe if I do the thing again with like line by line. So let's just copy that, paste it R here. This is like the second try, I think. Of course I tried it before. It's first try, we saved that. And yeah, thank you for watching. I'll just solve some other easier kata today. Have a good one.